Welcome to the fourth and final section of Chapter 2. We're going to be studying chemical reactions today. The goals for this section are to be able to describe what happens during a chemical change, identify at least 4 possible clues that a chemical change has taken place, and apply the law of conservation of mass to chemical reactions. Chemical properties describe a substance's ability to undergo a specific chemical change, to change into new matter with new properties. Flammability is an example of a chemical property. It describes whether substances will react in the presence of oxygen and burn when exposed to a flame. So things are either flammable or inflammable. Reactivity describes the ability of 2 or more substances to combine to form 1 or more new substances. Rusting is an example of reactivity, a metal reacting with oxygen to form rust. Elemental sodium reacts explosively with chlorine to form table salt, and even the green outer coating on the Statue of Liberty, that green patina, is created due to the reaction of copper with substances in the air. Galvanized steel is steel coated with zinc to try and prevent rusting. Buckets and nails are frequently galvanized. Steel plated with tin was once used in food cans and containers. However, today aluminum cans have replaced most steel cans because aluminum does not rust. How can you tell the difference between baking soda and baking powder if they're out of their container? Both are white powdery solids. One way is the reactivity with vinegar. Baking soda reacts vigorously with vinegar. Baking powder reacts slowly. Now, some books say that baking powder does not react with vinegar, but in actuality it does, because baking powder does contain a small amount of baking soda, which we know will react with vinegar. It just doesn't react vigorously. So chemical changes are different from chemical properties. Those two terms, although they're related, are not the same thing. Chemical changes are also known as chemical reactions. Those terms are used interchangeably. They are the processes by which 1 or more substances are changed into new substances, such as this egg that changes from a clear liquid with the yolk to a white solid along with the yolk, or this apple that turns brown after being exposed to the air for a while. This penny turning green as it's reacting in that container, or even wood burning in the presence of oxygen. Those are all chemical changes that are taking place. In a chemical reaction, 1 or more substances go into the reaction, and 1 or more substances come out of it too. If a substance is one of the chemicals going into a reaction, it is known as the reactant. Products are those things that are produced during the chemical reaction. So anything coming out of a chemical reaction is called a product. So if I asked you to identify the reactants and the products in these 2 reactions shown below, could you do it? In the first reaction, we see sugar gets heated and breaks down into carbon and water. So we have things on the left, which are the reactants, what's going in. There's actually only 1 reactant in this reaction, sugar. And we have 2 products coming out, carbon and water. In our second reaction, we could take that water that was produced before and we could further cause it to break down. If we applied an electrical current, then through electrolysis, we could get the water to separate into its 2 elemental components, hydrogen and oxygen. So in this case, the water is not a product. In this case, the water is a reactant because we're causing it to undergo a reaction, in this case, breaking down into 2 elements, hydrogen and oxygen. How do you know if a chemical change is taking place? One way is to see a change in the color or a change in the scent. Another is looking for the production of a gas. Fizzing, foaming, effervescing, as we can see when baking soda and vinegar are mixed, those are examples of production of a gas. Now that's not the same thing as heating a substance to get it to form a gas. We're not talking about taking an element or a compound and heating it up so it changes phase from liquid to gas. What we're talking about is having a reaction take place and a new gas being formed that we can then see the gas being produced. Another indicator of chemical changes is production of a solid. That solid is known as a precipitate. It is said to precipitate out of solution. Also, you may have production of heat in a chemical change, or production of light or sound as a chemical change takes place. Now, these things don't have to indicate a chemical change, just as a color change does not have to indicate a chemical change, but it is an indicator that there's a good possibility, so you might want to look at other things and see if you think a chemical change has taken place. Both production of heat and production of light or sound involves a transfer of energy. We will watch a video tomorrow in which you can try and see what indications of chemical change occur within that video. When you observe one of the indicators of a chemical change, then it is likely that a chemical change has occurred, but it's not absolute proof. The clue could be a result of a physical change, as I mentioned before. Energy is always transferred during a change of state, but a change of state is not a chemical change. Energy also may be taken in or given off when one substance dissolves in another. So, as you dissolve something, no chemical change is taking place, yet a change in energy and therefore a change in temperature does occur. So, keep in mind, changes in energy do not have to indicate a chemical change has taken place. New substances created, that's what determines if a chemical change has taken place. Test the composition before and after the change if you want to be sure. Matter's identity is changed in a chemical reaction. Reversing a chemical reaction, meaning getting back what you started with, is not always going to be possible. With some things it can be, like water can go through electrolysis and break down into hydrogen and oxygen gases. But if you ignite hydrogen and oxygen gas when they're mixed together, they will quickly form water vapor again. So in some reactions, it is possible to perform further chemical reactions to get a reaction to go the other direction. If it is possible, remember that it's going to require more chemical changes. Could you reverse the explosion of fireworks? Can you get all the parts of fireworks to go back together and all the new substances that were formed to get changed back into their original form? I'd say that's an example of a chemical change that's not going to be easily reversible. The law of conservation of mass states that in any physical change or chemical reaction, mass is conserved. What that's telling you is mass is neither created nor destroyed in any type of physical or chemical change. The fact that mass is conserved during a chemical reaction is easily observed if a change occurs in a closed container. As we can see here, we have two closed containers, each contain two clear liquids. They have a total mass of 43.43 grams. When the vials are opened up and one vial is poured into the other, and then they're both capped back off, put back onto the scale, then we see the mass inside the vials, all total, is still 43.43 grams. So mass has been conserved, even though we can definitely tell that a reaction has taken place because we no longer have two separate clear liquids. We have one vial containing a substance that is now yellow. Can you identify the reactants and products of the reaction that follows? Also, let's figure out one possible clue for a chemical change having occurred. As we look at this, I have two reactants. Those reactants are found on the left side of that arrow because the arrow is pointing away from them. So they are reacting to produce something. So methane and oxygen are both reactants. What's being produced? Well, the products are being produced. What are the products? Carbon dioxide, water, and even energy. So what's the possible clue for a chemical change occurring? One thing you might suggest is energy is being evolved. That can be an indicator of a chemical change. If you know much about these substances, methane, oxygen, and carbon dioxide are all gases. Water, if you gave it enough time at a normal temperature, would condense back to a liquid. If it started out as a gas because of high temperatures, it would form a liquid. And so that's also a possible indicator of a chemical reaction having taken place. I hope you've enjoyed the material from Chapter 2. This ends the new material. You should begin preparing for your test at this time.